Okay. Good afternoon, everybody. Thanks for having me here. My name is Xue Yin. I work in biomechanics lab with Dr. Huang. My today's talk is about the energy metabolism of invertebrate disc cells. Invertebrate disc sitting in between the vertebral body of the spine, it transmits loads and transfers spine flexibility. It can be visually divided into two regions, the central nucleus pulposus region, which is gel-like, and the surrounding fibrosis, annual-fibrosis tissues. The two regions differ in their cell phenotypes and extracellular matrix components, which are myelin, protein, glycan, and collagen. So IVD generation is associated with low back pain, which has the incidence rate of 1.39 per 1,000 people each year in the US. 10% of the sufferers eventually develop the chronic disability. So IVD degeneration, the exact reason is unknown, but the several factors have been identified to be associated with them, such as loading, trauma, aging. Among them, nutrition plays a major role. IVD is avascular. Because of that, it can only get nutrition from the periphery and the top and bottom end plate area from the blood vessels. They mainly use glycolysis and as their major energy source. IVD degeneration is characteristic by the loss of mitochondrial NP cells in the center and their ability to produce protein glycan. And subsequent loss of dehydration and tissue loss lead to the stiffness of IVD. Because of that, the biological repair of IVD aims to restore the IVD cells' ability to reproduce their extracellular matrix components, mainly protein glycan, as this protein can absorb water and pressurize in response to pressure. So we already know the low nutrition in terms of low glucose and glucose supply are detrimental to IVD cells' metabolism. In addition, the ECM production of the cells are known to be related to their intracellular energy levels. Because of that, we also know ATP is the building block of protein glycan. So in this study, we investigate the interrelationship between the ATP and protein glycan synthesis of IVD cells under the altered glucose and oxygen environment. So we harvest the IVDs from the pig and cut the cells into the 3D agar gel mode to keep their 3D phenotypes, followed by 6 days of incubation under the oxygen level 21% and 5% in a sequential reduction of glucose starting from 1 gram per liter, which is 5 millimolar. We found in this study that actually a threshold glucose value, which is 2.5 millimolar, is a key glucose level that below this level, mitochondrial NP cells' ability to produce protein glycan is hampered. Also, mitochondrial NP cells and AF cells respond differently to altered nutrition environment in terms of ATP and protein glycan production. So targeting their intracellular ATP level may help boosting their ability to reproduce protein glycan. Thank you.